All right. You guys enjoying your cookies? All right, this talk is baking your anomalous cookies, or how I learned to stop worrying and love fraud. My name is Allee, Jimmy two times. My contact is posted. I've been doing this for like 25 some years. TV, post that, half the family. Former U.S. National member, and some videos there today for good tricks, codes, and strategies for Nintendo games. I do follow the white rabbit, press the red button a lot. I like breaking, making, exploiting, resolving. I like the full circle, the full cycle. Raspberry Pi hobbyist enthusiast. I like functional wearables. Currently working with digital silence and thought for security. Thank you guys. I love you guys. Thank you for the opportunity. Next 45 minutes, we're going to cover fuzzing a little bit, how to break shit, a little bit about cookies, script I wrote to fuzz them, self-XSS and how to actually weaponize it. Something I call cookie baking. Talk about Google Chrome and how they handle their cookies at rest. Some PowerShell, Ducky scripts, read injectors. Talk about bug bounties a little bit, that process, and how to protect your cookies going forward. So once again, thank you all for showing up. Thank you, NolaCon. Thank you, Eric and Rob. Thank you, family. Number one, fuzzing. What is fuzzing? Well, it is kind of a QA process around throwing everything and the kitchen sink against something to see how it reacts. It could be an input field on a website. It could be a doorbell. You ring the doorbell once quickly. You hold it for 5 seconds. You did it 14 times. The answer is yes. All of it. We do fuzzing because it works. It shows us where there are weaknesses in software and frameworks so that we can take advantage of that and build a payload to exploit it. Our payloads come from everywhere. They could be anything. They come from creative people, really. People willing to try 3 periods and a comma instead of just 2. Put it in a list and let it rip. The methodology behind fuzzing is, again, taking some original piece of data, massaging it a little bit, and sending it out there again to see how the original service or whatever it is reacts to your changes. So for instance, if you go to like epicgames.com and you get a cookie like _epicsid, it's got some random or not so random string in there. What happens if you modify that and request the site to give you the request again? A little bit about cookies. You guys are probably familiar with what cookies are. It's a way for a website to keep track of you, a state, a password, or some other personal information that could be in this token or cookie that they can use to identify you. A lot of it's for user experience. It could be for tracking. Lots of uses for the cookie. So, writing a fuzzing tool. We're trying to solve a challenge here. And in fuzzing cookies, we need a browser to go to a website, make the request, grab the cookies, modify them, send them back to the server again, and get some type of output. In my case, I wanted to get screenshots, a spreadsheet, and a CSV that we can sort through. The reason we do the custom fuzzing tools is sometimes our paid software doesn't find everything. Self-access findings are deemed as not important kind of right now. They're not really known as valid attack vectors, so a lot of things don't check that right now. A lot of security functions and control. Possible solutions for our fuzzing tool. We might use Selenium. It's a browser. It lets you make requests. You can do headless. You don't need a GUI. Python. Again, that might be part of our solution here. And we might need some good fuzz lists. So let's write a fuzzer. We use Selenium. Selenium can use proxy. So you can send it to Burr, or you can send it to Tor, some other proxy or service that you want to use. You can change the custom user agent. You can dump a screenshot of each request. You can't modify the header. You have to use the echo driver. You don't have to, but it works better. Python, again, it's easy to build dictionaries for the cookie value pair. throttle your browser request. I just love Python. Everybody's moving to Go, but I'm still stuck in Python. So we're going to write in Python. One thing to say is fuzzing is an art. I don't think anybody knows really better than anybody else. You might know through experience over time, 2% symbols in the URL bar will break web requests a lot and dump out verbose errors or other information disclosures. But somebody fresh might try 18 or 18,000 and end up getting a shell somehow. So anybody can fuzz and actually use that to their advantage. Let's talk about Anomalous cookie here. This is the script I wrote to the cookie fuzzing. What Anomalous cookie does, it makes a request with Firefox. Payloads, whatever's in the fuzz list. It'll save screenshots of each request and make a spreadsheet. You just provided a URL, a fuzz option to replace the cookie value with your payload, append it in front, or append it. When it's done, it will again create the CSV file for you to sort through all the results, and you have a screenshot directory to go through. I like to do things visually. So like when you're fuzzing and you have to sort through log files or numbers, it doesn't always tell us much. It might tell you that you have 1,000 pictures that are maybe the same, or not pictures but request data. But if you look at the pictures in a directory, you can see, oh, those two are blank or different from the other 1,000 of pictures you have screenshot. So you can quickly find anomalies visually versus using a log. That's why I'm using a screenshot, why that becomes important. You can download Anomalous cookie from Lost Rabbit Labs on GitHub, and there's a little info there on how to install it. All right, let's test it out. So let's pick a target. When you are doing this type of work, always use your own website. But we're going to use target.com. Sets everything up for the next request with the fuzz payloads, and then it starts going from there. So the actual command to run Anomalous cookie is right there. It's going to be the URL. It's going to provide you the total number of cookies on the initial request here. So 13 cookie names, and underneath each fuzz request will have cookie name, payload used, and how many cookies you got that line. So on the fuzz website, you get more cookies than that. So viewing the output, again, Firefox will refresh the request browser. These will show up in the directory. You can see over here, there's one that's white. This is what I was talking about. Screenshot for log file. That's way than noticing that 5 requests or 2 bytes off the other one. That doesn't often just look at those results. But that picture won't put that in. On the left there, you have the spreadsheet. Sort that again by cookie name, payload, or total number of users on that request. So when it's done, you get a screen on the left that shows how many you got on X. And in this case, we got 25. We started out with 13 in our original request, but by the end, we ended up with 25 cookies. So here we can sort the images by size to find possibly alike images. And then we can flip through them like a flip book. So back in the day, before we had internet and video games, we took pieces of paper and drew little stick figures and made movies and flip book. You can do the same thing by doing an image preview and then holding your cursor key, and it will cycle through all the images really fast. You can just stare at the screen and everything will look the same, but then all of a sudden it will flash up here with the login boxes. You'll see that visually. So if you look at this directory output here, there's a whole lot of white pictures in with the normal looking stuff. The way that we use that information is in this case, we look at the pictures and we can see there's a JSON parse. Go back to the spreadsheet and then cross-reference those requests that don't match up with each other. So now we know this payload on that cookie generates that error. So we know that there's some play possibly breaking view that XSS. We'll run another test. We did target, found a little anomaly there. Epic Games, I spent a lot of money on the daughter's Fortnite account, and I really wanted to make sure that I'm not going to get robbed, or I'm kidding. I just wanted to mess with my daughter. It's true. There was a bug bounty also for them, and I figured I would just dive into this Epic Games thing real quick. After the second request, I got an XSS pop-up on epicgames.com. And then I found multiple payloads to work with that. Then the next thing I did is I went and pivoted off the cookie name. There's a few sites out there that you can do that, and I found that cookie was used. Cookie, and they were all vulnerable to the same exploitation. So the problem here is that I did this to myself. This is called self-XSS, and nobody gets excited about this. They don't take it seriously. Nobody gives a shit. So my inspiration was to try to turn this into a valid attack vector when I'm being told it's not going to be accepted as such. So my next steps are going to be to write a proper payload, and then I will reach out. I do responsible disclosure my own way usually. I will reach out. I will provide the information, ask for nothing, and just offer it as a courtesy. So again, I was talking about self-XSS not being viewed as a real, threat. So looking at what we found, we have this vulnerable cookie. We know it's vulnerable to XSS. And we know that we need to inject that cookie data into the stream or the cookie jar. So I know that I can do cookie stuffing, yeah? So if you're not familiar with cookie stuffing, you can trick the browser into allowing through iframe trickery and redirect trickery. We already know that can happen. So I feel like I can actually use this as a real attack. But I did want to look at it locally as well, since I found it locally. Once I weaponize it, I can defocking, I can steal the session token, I can steal authentication, and again, other creative things around injecting JavaScript. So anyway, I set out on a mission to make sure that I could really use this as an attack vector and steal my daughter's account. Yeah. I gave it back to her. It's fine. All right, cookies in the cookie jar. So what happens when you get a cookie from a website? It gets stored in your local cookie jar in the file system. I'll pick on Chrome here. Firefox is similar. They're all very similar. But you have this local cookie jar in your system. I mean, are they encrypted? What format is it? Are you allowed to write to that? Can you tamper with the cookies? Is on the encrypted value, which is the value of the cookie that you get from a web server. Everything else is unencrypted. So time stamping, all the other pieces here. Encryption is happening in Windows with the GT API. If you're local, you have access to. That's how everything gets signed in the Windows box there. Linux, we have static key and static salt. We have salty salts to do all this. And again, anyone locally can delete and create cookies in that cookie jar. There's no authentication on the database file. Right now, Chrome does not check cookies with XSS. No checks or flags that check the status or integrity of our cookies at rest. And there's no requirement small challenges have to be encrypted. So right now, we have secure and HTTP only on the transit of our cookies to check the integrity. But we don't have any flags for local tampering. We're not checking that at all. So we call it cookie baking. Cookie baking is a technique of creating or modifying a cookie in a local user's cookie jar. And of course, unauthorized. Injected with payloads, affiliate tags, other fuzz strings and payloads. And it also provides this delivery method for our self-XSS here, so that we can actually use it in an attack chain. Some of the delivery methods, so we can write a PowerShell script to do this. It's a very small script, it's like 8 lines. And then of course from there we can make a Metasploit module for post enumeration, rubber ducky scripts, weed injectors if you're familiar with that. And then we have AMT man in the middle now. And then of course we have keyboard and mouse hijacking. Traditional cookie stuffing will be a little harder maybe. So again, we'll focus more on the local. So Chrome again. The cookies are stored in that SQLite database in your user directory. They can be accessed with these 2 programs right here, SQLite browser, and SQLite library for PowerShell. On the bottom there's a view of the cookie browser and SQLite. Kind of hard to see there, but on the right is the encrypted value for the cookie. It says blob value. And then we have the name over there. So we're going to bake a cookie. We're going to use this PowerShell script in the PS SQLite. We're actually going to create a cookie called _epic_SID. This cookie will not be encrypted. We'll just use the null encrypted value and the normal value in the value field. We can actually check this cookie looking into developer tools or looking in the SQL browser, and you can actually see once you inject this cookie that it's there ready for the user to experience when they open their browser. If you go to the website, you're going to get this JavaScript alert box. That'll be your final proof. So we'll talk about the attack chain here. Get access to a Windows box, run PowerShell. You do need admin for this piece. There is the script right there. Again, 8 lines of code. Number 1, we have to kill Chrome. It locks the cookie jar, so we got to unlock it. We're going to install the PS SQLite module, set execution policy to remote sign, import our library we need for the SQLite, and then just do a simple insert statement. That's it. So with that little amount of code, you can actually inject any cookie into your local cookie jar. And again, you can delete an existing cookie and replace it with yours. So if you were, say, to do like a phishing campaign using this as an attack chain, you could literally cookie stuff somebody or cookie bake them with a session token that's for you or a spoofed website. The user will log into it thinking it's theirs and operate as normal. Using the DB browser again, we can see in the value field, which is like the 4th one over from the left, there's a script tag in there. On the right, the encrypted value is the second from the right, and it will say null in that column. And again, that's all you need to be able to do the cookie baking. Opening up Chrome's developer tools, we will also be able to see that Epic SID cookie in there with the malicious payload. So when the user opens their browser and goes to epicgames.com, they get that. You can validate it through the source code as well, what the payload looks like and how it breaks the view. From there, you can actually write a more proper payload then to do the session stealing or the beef hooking. So, post-fight here, we want to automate this attack. I don't want to have to type all that out anymore, right? So I created a few files here for weaponizing this. We have cookiebaker.duck, which is a rubber ducky script. My brother Poncho, Victor Tyser over at Coalfire, wrote something amazing called Death Metal. It is AMT man in the middle. And if you're not familiar with AMT, please go look it up after this talk. and go look at Victor's research on it. He did an amazing job there. Thank you, Victor. He helped create another conduit for my attack vector to work. So the cookiebaker.ps1 is just the PowerShell script, which again can be used with Metasploit. You can do local, other methods there as well. And then with the weed injector, wireless, HID device there that does a rubber ducky, I have a script for that as well. And the cool thing about the weed injector is you can actually take this thing and plug it inside somebody's motherboard. It creates a hotspot to a rubber ducky so that you have persistence. So if you can get the the weed injector on the motherboard, nobody's going to see that thing, and you have persistence to constantly update some user's cookie jar. This is what the ducky script looks like. It's not super complicated. It's just a PowerShell script again with some delays. And again, we saw that earlier. That's the PowerShell script. It's kind of the baseline for the rest of them. And there's the weed injector script right there. So again, that's the wireless HID. It has a web interface on it. You can upload your code as you need to, and then deploy the payload. If you end up finding some new cookies that are vulnerable that you know these users actually use, you can update them anytime. So how do we fix this? Is this even a real problem? So some of the difficulties around trying to fix this is there's confusion around the browsers and how they all handle this. They handle it slightly differently. Operating systems are a little bit different as well. Again, with Linux, you have the static key. Windows is DP API. I feel like there's some apathy around this issue as well, where browser manufacturers and other folks will say, well, users already have the ability to modify their code locally. That's their fault. But we're talking about the cookie jar, which is pretty much a key vault, right? I mean, we got passwords in there. We have personal information. We have other things that probably should be a little more secured, a little more locked down. That we can verify the integrity of that cookie jar when the browser closes, and then check it when it's opening again, and make sure nothing's been tampered. Does anybody do that currently? Does anybody actually check their cookies to make sure they've not been tampered with? Negative? Is there a reason we're not checking that? So I'm very excited about trying to find cookies. I feel like cookies are important. They're not going anywhere. But we need to do something. So, again, checking the integrity. Maybe we can do a browser plugin. Maybe an app. We can do some monitoring around it. Maybe we can test that local cookie jar. Put authentication on it. As a user, I don't feel I need to be in the cookie jar. The web servers need to do that with the browser. That's their, play. I shouldn't be in there as a user. That's my belief, yeah? So maybe Google can password protect that thing a little better, encrypt it better, or maybe we use something more than SQLite. Possible. So I went down this path of responsible disclosure, and this is the way I normally do it. I use OSINT or just Google, find the best contact, and I usually will reach out directly to who I feel is the appropriate person. And that's just from experience and working in this industry for 25 plus years. And so far I've been pretty lucky with hitting the right folks with that. So I sent out an email directly to the company. And then I also went and looked for the bug bounties that were behind these. I ended up finding Open Bug Bounty here and submitting my vulnerabilities with them. This was back in December. I provided all the detailed information about the vulnerabilities. The document on the right there is a comical way that I use to submit this to Google. I didn't want to just send them some boring thing. I kind of wanted to hype it up a little bit, so I made this PDF that looked like an old newspaper declaring that we can weaponize self-access now. Google responded within 1 day. You are correct. XSS Auditor does not detect payload in cookies, nor are there plans to do so. Note there that says open my PDF saying it contained a vulnerable site in the wild. They put an embargo on my report, restricted access to it, and then they closed it instantly with a won't fix status. So maybe this isn't a problem. Maybe I'm full of shit. You don't need to listen to me. The Open Bug Bounty in Epic Games. So I got an email back from Open Bug Bounty about, yes, they were doing the program and I needed to give them more information. I never heard back after I gave them all the information. I hadn't heard back from Epic Games either. I didn't get a reply. I'm not sure if I sent that email to the correct person. But it looks like HackerOne is doing the bug bounty for Epic now. I did see that recently. And I'm not sure if they were originally doing it because I didn't see their name out there for that. So maybe I didn't put enough work into figuring out who was running their bug bounty. But I got no cookie. Can I have one of those cookies actually? Like, I'm feeling left out now. Now I can get a cookie? Oh, thank you. Thank you, brother. We're busy. Like, I do this as a full-time job, so when I do things on the side or as a hobby, I can't spend as much time trying to help remediate some company I don't work for. So all I would ask is that the companies make this a little easier for us, make this a little bit more of a streamlined process. Again, I disclosed this back in December, never got any responses back. Published my work back in December 2018, and I definitely have to give a shout out to Bryce over in research there for supporting my work. I ended up releasing a new version of Anomalous cookie. Wrote this blog here, and again, that's what I got. That was my cookie. I got the blog. So here is where we're going to talk about other tools to secure and inventory your own cookies or somebody else's. I like to do things on both sides of the fence. When I find an attack vector and I create a payload, I like to instantly create the remediation for it. It makes for a better cat and mouse game. Otherwise, it's boring. These guys win, nobody's doing it. Throw it out there and we can evolve quicker, yeah. So I called it Cookie Hunter. I have a script that goes out and it will use sublister or some other OSINT ways of finding subdomains, and it will inventory all the cookies on your domain. Cookie Tosser will then allow you to log into one of the sites in the domain, take that session and spray it across, again, the entire domain space there. So if you do this with like Twitter or Facebook, it's really interesting. So you can use Selenium for this, log into Facebook, and then you use that same token and spray it across the entire Facebook.com domain space. And you log into some weird stuff, yeah? You get a lot of interesting screens out of that. Twitter's the same way. They have so many subdomains and posts out there that you actually have access to that you're oblivious to. So these kind of tools will help show across entire domains where vulnerabilities might be by the cookie name or some other data point. And then Cookie Paladin, we're going to check the integrity of this cookie jar. If we don't, we have no idea if things have been tampered with. So it's going to create some type of fingerprint of the cookie jar, and then also do some monitoring around it. Keep track and maybe alert if your cookie jar has been tampered with. Again, on the blue team side, we have digital footprinting and asset management with that, security auditing, and helping you minimize risk. The red team side can use it to find exploitable cookies across the domain quickly. And of course, if you're on like an internal test and you end up getting DA, you can spray this across the domain. Once you have that, you can create persistence and actually privesc on OpenShift. So just reiterating here, red team uses Metasploit module. Get on the domain, spray it. You have persistent potential access to many systems there. Using the weed injector. Again, getting it inside the box is better. More than like One way to use this is to create a database initially of every known vulnerable cookie that you can and put it into the payload list. Otherwise, you can be targeted. Again, we find one on epicgames.com. We can just stuff that cookie. But it'd be better to use, a good database and stuff everything vulnerable. And again, once you have the cookie baked in there and you can do the XSS, you can use beef, let's say. So this is one of the things I did with my daughter, is I made a custom DLC pop-up with beef that said you can get more floss dancing if you click here, and then that gave me a Metasploit shell. So it's really not that hard to get people to click on these boxes. Again, blue team, just to reiterate here as well. Opening up again. Checking the cookies all the time when the browser's closed, looking for any tampering there. I'm big with honeypots too. I would rather know who's trying to get at this stuff before they get the real stuff, so you can deploy honeypots around this as well. Just to see if anybody's secret and alert you to that. And again, maybe we shouldn't rely on local cookies for authentication or storage of important information, PAI, PHI. There's a bunch of stuff in cookies, so take a look. And again, OSINT around this. There's a couple websites there. You can go into any crawl databases, census.io, Google as well, and you can find, potentially if you find a vulnerable cookie, you can go find where else it may be used. And again, maybe used on other domains, other companies. They share the same web framework. I used to do a lot of work in anti-affiliate fraud, but this just made me realize, if somebody started cookie baking affiliate tags out there, they probably would make some money. Yeah, it's kind of an incentive for us to fix this maybe. And I'm going to do a demo here, yeah? So this is the last slide, but I'm actually going to do a quick demo, if that's okay. And we're going to see, there were two domains I disclosed. One was epicgames.com, and the other was .com. One second here. And it looks like my internet from Chester is down. Chester, where's your internet? Crickets. All right, we'll try here. Hey, homeless. Can you see if he's out there real quick and if he's got his hotspot on? Thank you, sir. Bear with me, sorry. I'll do it on whatever internets we got. Let's see if I got fingered. I think I'm good, sir. All right. Thank you for that. Appreciate you, man. All right. So, we're actually going to do a quick run of the script here. This is the actual command right here. Again, -1 was put the payload in front of the original cookie value. 2 is replace it. 3 is put the payload after. Let me slide this over. We will have a folder that gets created here. And then we will have a browser open when I hit this button. So, go ahead and hit the button. Anomalous cookie starting. Makes our output directory here. I'll slide this over a little bit. Looks like this internet might be a little slow. Let's see. Chester, is your internet up as well? I love you. There you go. Good job. All right. Thank you for your patience. Oops. It's a little slow as well. Let's see. Yeah. Oh, you're right. Joe Boo, where are you at now? Demos at NolaCon. We need Joe Boo. We don't have Joe Boo this year in a fried chicken. No, it's good. So I'll just kind of talk through this real quick. So this is clearly not going to work. I tried. Sorry, demo god. I failed you. So here's the thing. We get about 4 or 5 requests and it's going to look like that. It says rut roll. But that is current right now. So I publicly disclosed this or privately disclosed it back in December and it's still not fixed. So I'm not sure how we move forward with all this bug bounty stuff and responsible disclosure and whatnot, but again, December, this was disclosed. Today it's still rut roll. Let me go back here then. Thank you guys for your time. If you have any follow-up questions, I'll stick around for that here. My contact info is there again. Contact my I would also like to say, it is almost his birthday today. Yeah? Almost Hacker's birthday. Happy birthday, brother. I love you. And I just want to say this. This is, I did my first talk publicly 2 years ago here at NolaCon with Homeless Hacker. It was a huge privilege, man. So thank you for everything you've done for me here. And I'm proud to be working with you. And thank you, Hacker family.